Section 35.3 Rate Laws. How R depends on the concentrations of reactants. This table summarizes the rate laws for the 0th order, 1st order, 2nd order, and down there 3rd order reactions. Let's look at 0th order. 0th order means this R does not depend on the concentration of reactants. So R is equal to K. This K is the reaction rate constant. What about the unit of the K? The unit of K is the same as the unit of R by looking at this equation. Therefore, K is also in molar per second. Now let's look at the first order reaction. R is equal to K times the concentration of A to the power of 1, and thus first order. How do we determine the unit of K? Again, we'll do dimensional analysis. The unit of K is the unit of R divided by the unit of A. The unit of R is always molar per second. The unit of A is molar. Therefore, K is in second to the power of -1. Second order reactions. In this case, this R is proportional to the reactant A to the power of 2, and thus second order. In this case, the unit of K is the unit of R divided by molar squared. Therefore, the unit of K is molar to the power of -1, second to the power of -1. This is also a second order reaction because R is proportional to A to the power of 1 and also B to the power of 1. 1 plus 1 is 2. Therefore, it's second order overall. But also you can say it's first order with respect to A and also first order with respect to B. The unit of K is again the unit of R divided by the unit of A divided by the unit of B, and therefore it's also molar to the power of -1, second to the power of -1. Third order. This is a third order reaction, but also you can say it's first order with respect to A or B or C. Overall, it's third order. The unit of K is the unit of R divided by the unit of A, the unit of B, and the unit of C. And therefore, the unit of K is m to the power of -2, second to the power of -1. So again, R is the reaction rate. This K is the reaction rate constant. How do we measure the reaction rate? Let me give you an example for this reaction. From 2A to P, we can measure the concentration of A or P and how these concentrations change with time. For example, dP over dt is the reaction rate. And also, -1/2 times dA over dt is also the reaction rate. There's a negative sign here because A is consumed. There's 1/2 coefficient here because when 2 moles of A are consumed, we can produce only 1 mole of P. Now let's look at the reaction orders. Let's say we have this reaction from A plus B to C. And let's say this reaction is not necessarily an elementary step. So you cannot just say, well, the order is 2. It's first order with respect to A, first order with respect to B, only if it's an elementary step. But what if it's a complex reaction mechanism? And then we can write out this equation, really general. The reaction rate is equal to K times A to the power of alpha times B to the power of beta. And then let's just determine the value of alpha and beta. How do we do this? Well, we first take the logarithm of r and the logarithm of the right-hand side. And then we get ln r is equal to ln k plus alpha times ln a plus beta times ln b. By looking at this, you will realize if we have this concentration of b held constant, this ln r is simply a linear equation of ln a. Not only it's a linear equation, we know the slope is going to be alpha. So basically, you just need to plot this ln r versus ln a. Do a linear regression. Determine the slope. The slope is alpha. And similarly, you can hold a constant and then plot ln r versus ln b, and then determine the slope. The slope is beta. So this is how we use a spreadsheet to determine the values of alpha and beta for this chemical reaction mechanism. And alpha plus beta is the overall order of the reaction. Another way to calculate alpha and beta is this. Again, we need to hold b constant to determine alpha. When b is held constant, you can see this alpha is simply, well, over here, this is the difference in ln r. This is the difference in ln a. So basically, this is the slope of ln r versus ln a. And when you do that, over here, this is ln r2 minus ln r1, right? And then it's simply ln r2 divided by r1. Over here, this is ln a2 minus ln a1, which is equal to the logarithm of the ratio between these two concentrations. So basically, if you can hold a b constant and then you change the value of a, you get different reaction rate. And then once you have the two different reaction rate, take the ratio and then take the logarithm of the ratio. Put it on top. Take the logarithm of the ratio of the concentrations on the bottom. And then after this division, you will obtain the value of alpha. Similarly, if you hold the concentration of a constant and use two different concentrations for b, determine the two different reaction rates, you will be able to determine the value of beta. And again, alpha plus beta is the overall order of this chemical reaction mechanism.